Welcome back, students. What we're going to do now for the rest of this chapter is we're going to look at the main characteristics of rational functions. And I've listed them here. These are all the things that we've been practicing and learning how to figure out. Vertical asymptotes or points of discontinuity, because they kind of go hand in hand. Horizontal asymptotes, oblique asymptotes. So that's the family of asymptotic stuff. And on top of that, x-intercepts and y-intercepts. What you're really getting here are all the ingredients to produce the graph. Now, on some occasions, I'm going to ask you to draw the graph because it's simple enough that you could do it. More complicated graphs, I might ask for a good educated guess what it looks like, or I might not ask for it at all. So it depends a little bit on how complex the function is. So I'm going to do all of this, and then I'm going to do a probable graph for you, even though I think this is an example where it might be a little bit too complicated and you would actually really need a graphing calculator to see for sure what the graph looks like. So I'm going to clear the screen and give you the function. So the function we're going to look at today looks like this. F of x equals, and we've got x squared plus 4x on the top. And on the bottom we've got 2x squared plus 2x minus 24. All right, so we got a little bit of work to do. I think first of all, you would really be wise to factor it right away. So I can take out the common x on the top, because you know you're going to have to factor the thing eventually anyway, so you might as well do it right away. Let's see, I can factor out a 2 on the bottom, so let's get that out of there. So an x squared plus an x minus 12, and this looks like something that I can factor along the bottom as well. So let's do more than just factor out that 2. We can break this up, the trinomial, into an x times an x, and then I need two numbers that make negative 12 that add up to 1. I'm thinking plus 4 and minus 3. So I can go, hey, these cancel. All right. So I'm left with this as my simplified function. All right. So in the process, I've kind of figured out a couple of things right off the bat. Let's start off with vertical asymptotes. Okay. All you got to do is look at your simplified function and say, you know what, 3 is still a problem area. It didn't just cancel off. It's still hanging around. So that's a vertical asymptote. So that's not too bad. And then I look at, you know, at the same time, I think we did cancel something. So that is a point of discontinuity or a hole in the graph. And that hole is right here when x is negative 4. Okay, so when x is negative 4, all I've got to do now is figure out the y that corresponds to that. Now, how you get that is you go to this part of your function where we already canceled off the troublesome x plus 4. So if I plug negative 4 in for x, let's see what we get here. 2 times negative 4 minus 3. So this looks like negative 4 over 2 times negative 7, or negative 14, and that would simplify down to 2/7. All right, so we did the verticals, did the point of discontinuity. Let's have a look at horizontal asymptotes. Okay, so what we're looking at there is we go back to the original function, and we look at what dominates on the top and the bottom. You can see I've already alluded to them, and they're the same degree. So I want to keep the coefficients. So I want to look at it and say I have x squared dominating, and I have 2 over 2x squared dominating on the bottom. Hey, those x squareds cancel, so this thing behaves an awful lot like it wants to equal 1/2. So this would would be a horizontal asymptote. Okay, so we're just zipping along here. All right, so now I got to look at oblique. Oh, wait a minute. I don't think we have any because we just established that if you look here or you look back at the original, they have the same degree on the top and the bottom. So as far as oblique asymptotes, there are none. So then, let's see if we got any x-intercepts. Now, x-intercepts are numbers such that the entire function turns to 0. Okay, I'm looking for the x's. And what we would be looking for is, if we look here, for example, if I made the top 0, then the whole thing would become 0. And 0 is allowed, so I think we have an x-intercept when x is 0. I don't think we have any other place because -4 is already part of a point of discontinuity, so that's been used. And the 3 that's a vertical asymptote. So only when the top is 0, so 0, 0. And y-intercepts. Now y-intercepts are when you plug in an x value of 0 and you figure out what the corresponding y value is. Well, we already did that. When you put a 0 in for x, coincidentally it's the same as the x-intercept was. So both x and y-intercepts are going through the same point. So we've done it. We've done all of the characteristics of this graph. And what I'm going to do for you here, although like I say, without a graphing calculator, it's just kind of a guess, but this could be the graph. Now I actually know that it is the graph because I used my graphing calculator. But on a test or something, I certainly wouldn't expect you to get this right. But what I would expect is that you could give me a pretty good guess. So I'm going to mark some coordinates here, like that could be a 1. And then I'm going to mark down, I have to go at least to 4. So 1, 2, 3, 4 on the left. And I got to get to 3 on the right. Okay, so now let's put in all the ingredients. Vertical asymptote is at x equals 3. So let's just mark that guy. Okay, so there's the, vertical asymptote. Point of discontinuity is at -4 and up to 7. So right about there. So there's a hole in the graph there. I'm going to mark down the x and y intercept point as this point here. And then the next thing here is this horizontal asymptote at 1/2. So at a height of 1/2, I want to go off forever to the right and forever to the left. So roughly about here. Okay, so if I try and put it all together, here's a pretty good guess of what the graph is. I've got to join this point to 0, 0, so let's do that. So it kind of looks like it wants to head on down, and indeed it does. And this looks like I want to steer towards the horizontal asymptote. And so often these graphs, they're kind of, if you got one side that's going flipped over like this, typically the other side is flipped the other way. So again, it's an educated guess, but this is what I think our graph looks like. And I did look on the graphing calculator, and I'm correct. So that's where I'm going to stop for today. We'll catch you later.